So let's build on that story or the method further. And now I'm adding a one more mod function to it. So straight away my head should go, okay, now there are going to be 3 friends and I have to figure out their meeting for 3 friends. And once I figure it out for 3 friends and I understand, okay, logically there's not too much of a difference. Yes, there is one more character, more load, more calculation, just a little bit, but conceptually is pretty much the same. Then 4 or 5 will not make too much of a difference. So let's try this out. Let's first of all figure out the house locations. At x is equal to 1, this will become 0. So let 1 be a house, let 2 be a house, and let 5 be a house. Why are they houses? Because x is the meeting point. I want the distance of the meeting point from the house, so I need to know where the house is, right? This is A's house, this is B's house, this is C's house. Let's get them to meet step by step. Let everyone come to A's house. In that case, B will travel 1 unit, so plus 1, and C will travel 4 units, so 4, the total will be 5. So if they meet at A, the total distance covered is 5. Let me start thinking about C. If they are meeting at C, B will cover 3 units and A will cover 4 units, and my total will be 7. So this time notice I'm not getting a fixed value at the end of the ranges. If I meet at A, I'm getting the result as total 5. A is staying at home, so distance traveled by A is 0. Or x is 1, 1 minus 1 is 0, so this expression is out. But B is traveling 1 unit and C is traveling 4 units, so the total is 5. But if I go to C, B has to travel 3 units, 2 to 5, and A has to travel 4 units, the total is 7. So the logic is not exactly like last time, but I'm still very clear about the distance approach or the meeting point. Right now meeting point was A, that means x was equal to 1. For this story, x was equal to 5. Let's take the meeting point as B and see what happens here. If I stay at B, the meeting point is at B, A will travel 1 unit, so plus 1, and C will have to travel 3 units, so 3. So 1 plus 3, the total will be 4. So 5 and 4 and 7. So I am still getting that the minimum is between somewhere in the middle, because once you keep the meeting at B, B's distance is being eliminated from the story, right? Play around a little more. What if the meeting point is at x is equal to 3? In that case, B will travel 1 unit, C will travel 2 units, so 2 plus 1, 3, and A from 1 to 3 will also travel 2 units, so 3 plus 2, you are getting the total distance as 5. Go to x is equal to 4. I'm just playing with the data, trying to decipher if there is a quick pattern that I can recognize, right? I've already got the big idea, but just staying with the story a little more for that extra little observation. If I say x is equal to 4, B's distance would be 2, C's distance would be 1, so 2 and 1, 3. And A's distance would be 3. So 3 plus 3, the total is becoming 6. So I'm not getting a quick pattern. All I'm seeing is that, okay, if I think about it, the more the B's distance happens, the overall sum goes up. Because the A and C sum is always going to be 4, right? If you take C to A, the unit traveled is 4. If you take A to C, the unit traveled is 4. If you make them meet anywhere in the middle also, the unit traveled is 4, right? That's why if you keep the B as constant, you're getting the minimum output. But at any other point, I'm not getting too much of a breakthrough point as such, right? I also know that in this particular region, the minimum is 4, and that is also the absolute minimum. So if somebody asked you what is the minimum value of this function, you would have said the minimum value is at 4. And then now you can generalize the idea. If you have 3 characters, get them to meet at the guy in the middle, and that way you can minimize the distance, because A and C will have to cover 4 units or whatever is the distance between them. So they might as well meet at B if you want to minimize. But that was not our question. Our question was, now I have to make the total distance traveled 18. So obviously it's not going to be in this region. So now I will use the same story or the same mindset that I used last time. A travels from A to C's house, and the distance covered is already 1 to 5, 4 units is already covered, plus 4, right? So now I want to target this sum. I've already understood that, okay, 3 people, now I have to get 3 people to meet at a particular point. and find out the distance of that point from these houses, right? House of A, house of B, house of C. And again, I've seen the approach earlier. So I know in this region the meeting was not happening. Say it is happening beyond 5 somewhere, and it is happening at this point, and let's call it X. So if the meeting is happening here, A must be going till C anyway. So from 1 to C, 1 to 5, there are 4 units, right? So A has already covered 4 units just reaching here. Similarly, B has covered 3 units just to get to this point. So now A is also here and B has also reached here, and for B to reach here he has covered 3 more units. So 4 plus 3, 7 units are already gone. You started with 18, 18 minus 7 you figured out, so you have to take the remaining 11. Now at this point C and A and B are all together and they are traveling to point X. The distance for all 3 of them is going to be same. So if you call it R, this is also R, this is also R, and this is the total distance after this point. That means the total distance is 3R. And after this point, what is the remaining distance? Because I know to just get to this point, A will spend 4 units or travel 4 units, and B will travel 3. The total is 7. 7 is gone, 11 is left. 3R is equal to 11. So R is equal to 11 by 3, which is going to be, so R is going to be 11 by 3, which is going to be 3.66. And 3.66 from where? From this point, from the house of C. So from 5, 3.66 gives you X is equal to 8.66. Check, put 8.66 here and try and calculate the, so check for yourself also, put 8.66 here and try and see whether the value is right or not. Just as a cheat code, if I make it 19, why am I doing that? Because I know A has traveled 7 units, B has traveled 3 units, 7. If I make this 19, 19 minus 7 will give me a 12, right? And 12 divided by 3 is easy, you will just get a 4. So from 5, go 4 more, you will reach X as 9. Put 9 here and you will see you are getting a 19. This is just bonus play. This is the perfectly fine answer. I am making it 19 to make it comfortable for those people who don't like fractions as such, right? But if you make it a fraction free experience on this side, the other side will be troublesome. So let me go back to 18 only. Now let's think of this side of the story. Again, I know C to get here will travel 4 units. B to get here will travel 1 unit. So plus 4 plus 1. 5 units are already gone. Out of where? Out of 18. So 18 minus 5 gives you 13. And this remaining 13 units of distance has to be covered by A, B and C. Say the meeting point is here. A is traveling, B is traveling, C is traveling. C has already traveled to A's house, B has already traveled to A's house. The distance spent is the total of 5. Now all of them are traveling the same distance, 3R. This 3R is equal to 13 units. Don't stop, be relentless. R is equal to 4.33. So from this point, A's house, which was at 1, you go 4.33 in the other direction and figure out the value of X. Right? So you will realize that it is pretty much the same process. So what if there is an extra friend? I have extra brain cells, so I will deploy them and still work with the story. And even now, because again we are looking about the first time, I went slightly slow with the description. The next example with the same story will be faster. And my next challenge will be to change the coefficient and see then what happens. And by now I have enough experience with such games that okay, I know for that also there will just be a little trick to make it easy for me to symbolize it in easy expressions and then just play with it, right? So the same story, the distance story, now applied with 3 modulus. One more example, maybe one more example with this, and then we'll change the coefficients.